All right, good morning again, everybody. So, as I was saying last time, hindi pala last time, kanina lang before I started the recording. So we'll finish, we'll probably need 6 more meetings or 7 meetings to finish the course. So our timetable will be as follows. So today, tatapusin natin yung unit 3. So by tomorrow, May 6th, right? I'll give you the PS2, which will be live on Canvas. I'm not sure kung anong oras. Siguro around sometime during the nighttime. So siguro mga 8 p.m. or 9 p.m. at the latest. Tatry kong i-upload siya ng maaga. Pag-iisipan ko pa kasi kung anong laman ng problem set 2. But at least or at the latest, expect it at 9 p.m. tomorrow. All right. Tapos the deadline would be May 13th. Okay, that's gonna be next Friday. All right, para meron kayong ilan. Kung holiday yung election day, that you'll have four working days to finish it. Okay, so ano lang naman to? Ilan nga ba? Siguro 3 na lang na parts yung gagawin ko. 3 or 4 na parts so that you'll have a working day for each problem. Okay, so siguro yung part 1 will be an essay type. Part 2 and part 3 will be proving questions. And then part 4 would be true or false siguro. So, yun na lang. Or gusto nyo pa ba ng true or false? So, wag na lang. Medyo mahirap magsagot kasi ng true or false, ano, sumasabit minsan. Lalo na kung all or nothing. Which basically, yun ang mangyayari kung true or false, ano. Unless gawin ko siya modified true or false para may partial credit o kaya justified true or false wherein you have to put your reasoning if you think the statement is true or not. Okay? So, ano gusto nyo? Ano na lang? Essay plus 2 proving or essay plus 2 proving plus 1 true or false? Ano sa tingin nyo? Or wala pa kayong pakialam? So, pag wala kayong suggestions, ako na lang mag-iisip pa. So, by the way, special shout out to those who are having anxiety attacks due to the election or for those na mga excited para sa election sa Monday. So aside from doing your ACAD works, so I hope you guys will exercise your solemn privilege and civic responsibility of suffrage. So bumoto tayo sa Monday at sana bumoto tayo ng tama, So yeah. Okay lang ba to yung schedule natin? So this is gonna be a deadline of problem set 2. And then towards the end of the semester, siguro a week before the semester ends, so that would be on the first week of June, we'll have problem set number 3, the last problem set. Tapos we'll have the final exam kung kailan yung final exam ng registrar, okay? But don't worry, ang final exam lang naman lagi ang ginagawa ko sa 155. Reflection paper lang naman yung final exam. So you don't have to worry much about it. Probably 1 day is good enough for you. You'll just need to write a 1 or 2 page reflection about your takeaways from the course and whatever things you want to write. So, yun lang naman. At saka siguro yung evaluation survey para sa ating classes. So, yun yung coverage ng final exam. All right? Okay, so let's see what we did last time before continuing on. I think last time we talked about uniform continuity. Sinabi natin itong uniform continuity is basically sort of the analog ng konsepto ng Cauchy sequences for functions. Okay, so kailan ba nagiging uniform ang isang function or uniformly continuous ang isang function? Nagiging uniformly continuous siya kapag yung choice of delta for any given epsilon doesn't depend on the value or the limit point at which you're evaluating the limit at. So, kaya ang uniform continuity ay check hindi isang number it's uniformly continuous and interval if and only if the choice for delta given any epsilon, all right, is not dependent on the x value within the interval. So sa kahit anong x value sa interval, ipapakita mo na yung choice of delta para mapakita na continuous yung isang function ay hindi nagbe-matter. Kaya nga siya ang tawag ay uniform. For any x within the interval, there is a uniform choice for delta regardless kung ano man yung limit point na kinoconsider mo. And essentially, from a layman's point of view, you can sell the concept ng uniform continuity this way. Habang palapit ng palapit yung mga x's o yung mga values ng domain o ng interval sa isa't isa, dapat yung function values palapit din ng palapit. Remember, delta and epsilon are just our notations for very, very small numbers, right? So that means as we make two domain elements, say x and y, very, very close to each other, that will imply or that will necessitate the function values to be very, very close to each other as well. So if you have a target small distance between two function values within the interval, okay, then it suffices to find a small enough delta so that kukulungin mo yung mga x values within delta neighborhood or delta neighborhood within neighborhood para ay may distance na pin-reset mo o na sinet mo from the get-go. Okay? Now, usually the proof for uniform continuity is quite hard. Okay? Kasi nga papakita mo na mag-preliminary analysis ka and you should do the preliminary analysis in such a way that you remove the dependency ng choice for delta doon kay x sub 0 o kay c kung saan mo kinukuha yung limit. All right. So yung idea yun ng uniform continuity. And one thing is that a function may be continuous but not uniformly continuous. Uniform continuity is a next level for continuity. Kasi mas mataas yung requirements sa uniform continuity. Dapat continuous ka muna plus yung choice mo para kay delta ay hindi nakadepende dun sa x values, right? So you can be continuous but not uniformly continuous, but the converse is not true. Ibig sabihin kapag ka uniformly continuous ka na, sure na tayo na ikaw ay continuous. Okay? Because it's a higher level of continuity. And in the same light as what we did, let's say, merong analog, yung merong characterization ng uniform continuous functions with respect to sequences, all right? And that's theorem 3.8. Ang isang function from E to R ay uniformly continuous if and only if sa kahit anong dalawang sequences na kukunin mo dun sa set E, such that ang limit nung sequence of differences xn minus yn ay equal kay 0 ay laging nag-i-imply na yung limit ng function values o yung limit ng sequence ng function values ay nagiging equal kay 0. Okay? So this is a characterization theorem. So but I think the utility of theorem 3.8 ay yung forward implication na kapag ikaw ay uniformly continuous, pwede nating mababa yung konsepto ng uniform continuity into a sequence. And then we can play around the theorems that we learn from sequences para i-manipulate itong implication na to. And then after that, we can appeal to theorem 3.8 again para ibalik yung arguments natin from sequences papunta sa functions. In that way, yung theorem 3.8 is a powerful tool in proving uniform continuity. Okay? Pero hindi siya madaling maganda siyang tool para mag-prove ng mga statements o mga theorems about uniform continuity, pero medyo mahirap siyang gamitin para mag-prove ng uniform continuity. Kasi nga, dapat mapakita natin na sa lahat ng posibleng dalawang sequences na magiging totoo itong implication na to. And considering all possible sequences for a certain function or a certain set is not easy. All right. Now, the value of theorem 3.8 insofar as testing for uniform continuity actually lies in, ano ba to? Inverse, hindi siya converse eh. So para siyang inverse, which is basically what we have in corollary 3.5. It gives us a sequential criterion pero for non-uniform continuity. Okay? So ang isang function ay hindi uniformly continuous kapag nakakita ka ng dalawang sequences dalawang sequences lamang ang kailangan mo such that yung sequence ng differences ay nag-approach kay 0, pero yung sequence ng difference ng function values ay hindi nagko-converge papunta kay 0. Okay? I think ito na yung simula ng discussion natin for today. All right? Now, let's illustrate the use of corollary 3.5 via an example. So dito ipapakita natin na ang sine 1 over x ay continuous, pero hindi siya uniformly continuous sa interval 0 to 1. I guess you already met this function in an earlier example, but ang ginawa natin doon, pinrove natin yung sine 1 over x ay hindi continuous sa 0. Okay? So, pero dito, tinanggal na naman natin yung 0, hindi siya kasama dun sa interval of consideration, so we're covered. Tapos, siguro pwede nyo na rin itong gamitin sa mga problem sets, sa mga homeworks. Ano? So, ang mga pwede nyo na gamitin without proof ang mga sumusunod na statements. Kasi I think it was mentioned in one sentence above or earlier in the module or in the lecture notes that polynomials are continuous everywhere. Okay? Number 2, ano pa nga ba yung sinabi natin? Rational functions are continuous on their domains. Tapos isama nyo na rin yung trigonometric functions are continuous on their domains. Tapos siguro lahat na ng mga alam nyo na functions na continuous mula sa Math 36. Logarithmic, exponential, hyperbolic, ano pa nga ba mga functions? Meron pa ba logarithmic, exponential, inverse trigonometric, hyperbolic, inverse hyperbolic, yung mga functions, yung mga usual functions na alam na natin to be continuous from Math 36, huwag nyo na ipoprove unless yun yung problem na prove that this function is continuous. Pero kung gagamitin lang naman sa isang statement, pwede nyo na lang banggitin without giving up a proof. Okay? So, halimbawa dito, para mapakita na siya ay continuous, siguro sasabihin ko na lang na, note that 1 over x is a rational function whose domain is a superset of the given interval 0, 1. Thus, 1 over x is continuous on the open interval 0, 1. Tapos, note that, pwede nyo sabihin that sine of x is a continuous function everywhere, hence it is continuous on 0, 1. And since the function h is the composition of sine circle 1 over x, being the composition of two continuous functions is also continuous on the open interval 0, 1. So yun na, yung proof na ang h ay continuous. So just apply on the continuity of the functions involved in the definition of h plus the basic result na ang composition ng continuous functions ay continuous pa rin. Now, what's left to be shown in example 3.9 ay hindi uniformly continuous yung function h dun sa given interval 0, 1. Right? And of course, we will appeal to corollary 3.5. The approach is to think about two sequences, xn and yn, such that yung sequence xn minus yn dapat mag-converge kay 0. Pero dapat yung function values hindi magko-converge papunta kay 0. And the handout did the heavy lifting for us. Ito yung medyo, sabi ko nga, mahirap sa proofs analysis. Usually, mag-i-involve yan ng construction. So, pagalingan tayong mag-isip ng gagamitin na sequence, na function, or whatnot. Alright? So, ito yung kaibahan niya siguro sa algebra, sa modern algebra, linear algebra, and other courses. So, ito yung medyo kailangan mas creative tayo. Okay, so the handout gave the following example. Ang xn niya daw ay 1 over pi over 2 plus 2n pi. Pero kamukhang-kamukha ito nung ginamit natin last time, no? Para ma-prove na hindi continuous yung sine 1 over x sa x equals 0. So parang at least dito nabibigyan kayo ng idea paano mag-construct ng mga gusto nating mga sequences. So this is our xn, this is our yns. And then when we take their difference, so check lang natin. Sana tama. So this will be, pag pinag-minus ko sila, 3 pi over 2 plus 2n pi minus pi over 2 minus 2n pi all over pi over 2 plus 2n pi times 3 pi over 2 plus 2n pi. Parang bihira ako nag-work sa fraction. So hopefully tama yung subtraction ko, yung xn minus yn. And then in the numerator, those with n's will cancel each other out. And that will leave us only with pi in the numerator all over this product. But so the numerator is a constant, it's pi. But the denominator increases without bounds because here we have the variable n, and n takes any natural numbers. So when we take the limit as n approaches infinity, the denominators will increase without bounds. So we have pi over an extremely humongous number. So this will indeed go to 0. Okay, so fine. Nakita na tayo, dalawang sequences ng mabubuong sequence of differences ay magko-converge kay 0. Now, our fingers are crossed. Yung sequence ba ng differences ng function values mag-approach ba ng 0? If it does, then sorry, back to the drawing board tayo. Pipili tayo ng iba pang sequence xn at saka yn. But if we can find that the sequence of differences will not approach 0, then we're good. So we will be in a good place na. Ano? So let's see, f of xn. What is f of xn? So we simply plug in our xn's into the sign, but we'll have pi over 2 plus 2n pi, all right? Sorry, naka 1 over pa pala to. So essentially, this will just be this guy, sine ng pi over 2 over 2n pi. So we are always on this quadrantal angle. Paikot-ikot lang siya, right? So the sign there is always positive 1. And in a similar manner, so ito ay equal kay 1. In a similar manner, you can see that f of yn is equal to sine of 3 pi over 2 plus 2n pi. So we'll always be here in the lower quadrant. So that will give us a negative 1 value. So that means pag kinuha natin yung sequence f of xn minus f of yn is going to be 1 minus negative 1. So that will be a constant sequence consisting of all 2's. And a constant sequence of all 2's will not converge to 0. Then, nakahinga tayo ng mga yes, we have proven that indeed this function h is not uniformly contained on the given interval. Okay? So, argument this paano na and yn. Okay? All right, so does that make sense, guys? Any questions so far? Bakit ang bilis ng oras? 11:51 na kagad. Ang haba ba nung intro ko kanina? Anyway, so kung wala naman tanong. Okay. Now, the next result tells us that continuity, theorem 3.9 gives us a sufficient condition for uniform continuity. At dito natin makikita, ang dami palang nangyayari sa isang compact set. So remember, a compact set is a set on which every sequence has a convergent subsequence. So yun yung definition natin ng compactness. Now that's sometimes hard to visualize. We have a characterization for it saying that a set is compact if and only if it's closed and bounded. For instance, you have your closed intervals, right? Your finite closed intervals. So tapos nalaman natin last time na kapag ka meron ka isang continuous function at isang compact set K, ang f bracket K o ang image ng continuous function over a compact set ay compact din. All right? So kung si K ay compact, si f ay continuous, si f bracket K ay compact din. Hindi lang pala yun, yung nabibigay ng pagiging compact. All right? So yung pagiging compact also implies na kahit anong continuous function sa loob ng isang compact set ay laging uniformly continuous. And this is actually a powerful result. Imagine, it's quite difficult to prove that a certain function is uniformly continuous. But if you're sure that your function f is continuous and your domain of definition or your set of interest is a compact set, then automatically yung pagiging compact ng set at continuous, pagiging continuous ng function f guarantees that the function f is uniformly continuous. So, imposible magkaroon ng isang function na continuous pero hindi uniformly continuous sa isang compact set. Ganon ka sa kalam si compact sets. So, ang dami niya na preserve na maganda mga properties. So, katulad ng uniform continuity. All right. So, let's see the proof. I was thinking to rewrite the proof and present it from scratch. Kaya lang, merong mga corrections. Dito nga ba yun? Hindi naman. May mga notation corrections lang sa proof na to. Pero lagi ko kasi nakakalimutan na i-correct dun sa latest version ng lecture notes. So ang gagawin ko na lang, basahin na lang natin yung proof tapos i-annotate ko kung ano yung i-correct natin. But I think here, simple typos lang yung kulang. Dun sa IVT, medyo meron akong major na babaguhin. But anyway, so let's read through the proof. Of course, our assumption here is that f is continuous and k is compact. And our goal is to show that f is uniformly continuous. Okay? Now, ang proof niya ay by contradiction. So, i-assume natin si f ay continuous sa compact set k, pero si f ay hindi uniformly continuous. And our goal is to find or to fish for a contradiction. Okay? So, si f, kunwari, ay hindi uniformly continuous. Dahil si f ay hindi uniformly continuous, then dapat makakita tayo ng dalawang sequences na ang sequence of differences ay nag-approach kay 0, pero yung limit ng difference ng function values ay hindi nag-approach kay 0. So you can think of it as a version of, di pala siya version ng corollary 3.5, no? Kasi yung corollary 3.5 ay one direction lang. Kapag ka nakakita ka daw ng dalawang sequences such that this guy is true, then hindi siya uniformly continuous. Pero wala yung pabaliktad. Pero yung pabaliktad is an easy consequence of the sequential criterion, yung theorem 3.8. Okay? Kasi kapag ka ikaw ay uniformly continuous, kahit anong dalawang sequences, as long as the sequence of differences approaches 0, then yung sequence ng differences ng function values ay mag-approach din ng 0. Pero dito alam natin, ang assumption natin ay si f ay hindi uniformly continuous. Since f is not uniformly continuous, hindi guaranteed na kapag ka nakakuha ka ng dalawang sequence na equal dito, na merong property na to, yung limit ng function values nila ay equal kay 0 na. Okay? Or essentially what I'm saying is, since f is not uniformly continuous, then we should be able to find two sequences within the compact set K such that yung limit ng xn minus yn ay equal kay 0, pero yung limit ng mga function values or difference ng function values ay hindi mag-approach kay 0. Okay? So it's basically just a play on one of the contrapositives nung theorem 3.8. And then, hold on. Okay. And then, ano ngayon kung meron yon? Well, alam na natin itong dalawa na to. Pero ang hindi ko pa nagagamit ngayon yung pagiging compact ni K. Alright? So, dahil si K ay compact, so, ibig sabihin, merong subsequences, xn and yn. So ito yata yung kailangan kong i-correct. Highlight ko lang ng red. Okay. So meron tayong sequence xn and yn such that limit ng xn minus yn ay equal kay 0. Pero si k ay compact. So ibig sabihin makakakuha ko ng subsequence ni xn at subsequence ni yn na parehas magko-converge. And let's say they converge to elements x and y of capital K respectively. All right? Kasi yun nga yung kailangan yun yung definition ng compactness. Kahit anong sequence ay magkakaroon ng isang subsequence na nagko-converge sa loob ng compact set. So that's what I assume here, xn and yn both converging to k. Now, our claim ay si x at saka si y ay equal lamang sa isa't isa. Okay? So, because I will use it later to show na hindi posible na mangyari ito. Okay? So, we claim that x is equal to y. Now, paano ko siya mapapakita? Well, I can write it this way. remember y is the number that we assume to be the limit of the subsequence y sub nk. So I can write y equals limit ng y sub nk as k approaches infinity. Okay? Kasi nga si y sub nk nag-approach tayo kay y. So, okay, sulat ko siya in limit notation. Why do I want it to write in limit notation? Para mas makakuha tayo ng analytic analysis para sa kanya. Analytic analysis, hindi ba redundant? But anyway, I hope you get what I'm saying, you know? So tapos ngayon, mag-add and subtract ako. This is a usual trick that we're doing, right? So, mag-add and subtract ako ng isang number para yung net effect ay maging equal kay 0. So what, in particular, I will add and subtract x sub nk. Since magka-cancel lang naman to at saka ito, so babalik ako sa y sub nk. So I did nothing wrong or I didn't change the quantity y here. So y pa rin siya. Kaya lang, pag ginup ko kasi itong y nk minus x nk, pwede kong gamitin yung limit theorems natin. Okay? Dahil alam ko na itong y sub nk minus x sub nk will converge to 0. Bakit? Kasi yung parent sequences nila o yung pwede kong i-treat ito to be a subsequence ng yn minus xn. Right? Kasi corresponding pa rin naman subsequence ni yn, subsequence ni xn. So this guy can be treated as a subsequence of yn minus xn. All right? Kaya lang, ang alam ko sa yn minus xn by algebraic limit theorems for sequences, dahil si xn minus yn ay magko-converge kay 0, dapat ito magko-converge din kay 0. Diba? Kasi nag-multiply lang naman ako dito ng -1 para makuha ito. So kung nagko-converge ito, pag nag-multiply ako ng -1, magko-converge pa rin yung resulting sequence. At ang limit niya ay limit ng 0 ay equal kay 0 times -1. So essentially, yn minus xn will still converge to 0. Then we have a result from sequences that tells us na kapag convergent yung isang sequence, lahat ng subsequence niya ay magko-converge din to the same value. So now I can say that ynk minus xnk is convergent, and not just that, this will converge to 0. Tapos yung x sub nk, alam ko nagko-converge yan by our characterization kanina no compact set. So basically, this converges, so therefore, their sum will also converge. All right? Kasi nga, pag nagko-converge yung dalawang addends, yung sequence na mabubuo mo ay convergent pa rin. And not just that, they will that new sequence will converge to the sum of the sequence, to the sum of the limit of the two sequences. So dahil ito ay convergent, so the whole thing or the sum will be convergent and it will converge to the sum of the respective limits. This converges to 0, this converges to x, so the entire thing converges to x. Right? And essentially what we have now, y is equal to x, as we have claimed above. Okay? So sir, ano ngayon? Ang dami nating ginawa, maraming tayong sinabi. Bakit ko gustong mapakita na si x ay equal kay y? Kasi may isa pa tayong di nagagamit, yung continuity. Alright, tingnan niyo itong gagawin ko. So si f ay continuous. So yung sequence ng yung subsequence ng mga function values ay magiging convergent. Why? Because remember, halimbawa si fxn, isa yung sequence, alright, na nasa loob ng compact set na f bracket k. Kasi nga si f ay continuous. So, ibig sabihin, hold on, kailangan ko pa nga ba itong sabihin? Actually, hindi ko pala ito kailangan sabihin. Enough na yung continuity. Kasi remember, kapag ka si f ay continuous, tapos kumuha ka ng isang continuous sequence of domain elements, yung sequence of domain elements ay magko-converge doon sa function value nung limit ng mga x sub nks. Remember, yung characterization natin ng continuous functions, right? So si f ay continuous, yung x sub n's, yung x sub nks, yung sequence, yung subsequence ng mga function ng mga domain elements ay nagko-converge kay x. Kaya naman, yung sequence ng mga function values ng elements ng subsequence ay dapat magko-converge dun sa function value nung limit. Right? And that is also true for the sequence f of y sub n k. Parehas sila magko-converge kay f of x. Kasi nga ang limit ni x sub nk at saka ni y sub nk ay parehas equal kay x. Right? Now, there will be a contradiction here. Why? Because if I form the sequence of differences f sub nk minus f of y nk, all right, I know that this will converge by the algebraic limit theorems for sequences. Dahil ito ay convergent kay f of x, ito ay convergent kay f of x, then the difference will also converge. And it will converge to f of x minus f of x, which is equal to 0. And that's where the contradiction lies. Contradiction yan kasi sinabi natin earlier na ang limit ng f of xn minus f of yn ay hindi equal kay 0. Pero here we are saying that the sequence, the partial sequence, all right, ay nagko-converge papunta kay 0. Okay? So contradiction siya to the fact that the sequence is converging. The sequence converges to a number aside from 0. Okay? So therefore, since there is a contradiction in our arguments, then we are forced to conclude that this is indeed true. Okay? Or siguro to phrase it in a better way, okay? Hindi, wag na lang pala. Okay na yun. Unless you have some questions. Masyadong mapapahaba pa yung discussion. Okay, does the proof make sense? Okay, I hope it does. All right. So I'm thinking there's a shorter way to prove this, pero dahil nandito na yan, hindi ko na ipapakita yung mas maiksing proof. Ano? Pero I hope the idea makes sense. Ang kagandahan sa proof na to, nadaanan natin yung konsepto ng compactness, ng continuity, alright? So nagamit natin yung mga essential properties ng dalawang concepts na iyon. Okay? So let's see. If there are no questions, let's look at example 3.10. Ano? So dito, tiningnan natin yung quadratic function again. We have already noted earlier that x squared is not uniformly continuous kasi nga yung choice para sa delta na nakukuha natin sa mga preliminary analysis ay nakadepende dun sa limit point x sub 0 kung saan mo tinetest yung continuity, right? So hindi siya uniformly continuous, kaya lang mahirap yung ipakita. Kasi yun nga, kailangan mo ipakita na imposibleng makakuha ng isang delta na hindi nakadepende kay x sub 0. Kaya ang ginamit dito ay sequential criterion for non-uniform continuity. Okay? So paano kinonsider yung dalawang sequences? N plus 1 over n at saka n. Note na yung xn minus yn ay equal kay 1 over n. Tapos si 1 over n nagko-converge kay 0. So indeed, we have xn minus yn converging to 0. Now our prayer is that f of xn minus f of yn will not converge to 0. Yan yung gusto natin sanang mangyari. But I think that's fine because if you compute f of xn, plug in lang natin to kay x squared, we'll have n squared plus 2 plus 1 over n squared. Tapos ang f of yn ay n squared lamang. So we take their difference. This would be 2 plus 1 over n squared, which will converge to 2, not equal to 0. So indeed, x squared is not uniformly continuous. And this is the beauty of the sequential criterion for non-uniform continuity. Hindi na natin kailangan dumaan dun sa paghihirap na pagpo-prove na imposibleng makakuha ng delta na hindi nakadepende kay x sub 0. Alright? So yan, sure na tayo. May madali tayong proof or definitive proof na yung x squared ay hindi continuous or hindi uniformly continuous. Pero continuous siya, hindi nga lang siya uniformly continuous sa interval 0 to infinity. Okay? But the interval 0 to infinity is not bounded. Therefore, it is not compact. All right? Pero in Theorem 3.9, we learned na kahit anong continuous function ay nagiging uniformly continuous kapag yung domain ay ginawa nating compact set. Right? So we can illustrate that using the quadratic function. Okay? So kapag yung domain ng quadratic function ay ginawa nating negative 10 to 10, closed interval negative 10 to 10. And note that this is compact. Right? Ibig sabihin, kahit anong sequence na napapaloob kay negative 10 to 10 ay magkakaroon ng isang convergent subsequence na nagko-converge sa isang number sa loob ng interval na to. But again, that's hard to imagine, so gamitin natin yung characterization ng compact sets. Ang isang set ay compact if and only if it is closed and bounded. This guy is bounded, all right? Negative 10 to 10, finite lang yung interval, so it's bounded. And it is also closed because it's a closed interval. Okay? So sure tayo compact, yung negative 10 to 10. Tapos si F being continuous on its domain, which is essentially all real numbers, so F will be continuous on this closed interval as well. So by theorem 3.9, then we are sure that F is uniformly continuous on the closed interval negative 10 to 10. So si X squared, hindi siya continuous sa set of all positive real numbers, pero hindi siya uniformly continuous sa set of all positive real numbers, pero siya uniformly continuous sa closed interval negative 10 to 10. Okay? And then since we are claiming that this is uniformly continuous on that interval, that means on the interval negative 10 to 10, we can pick any x na mapapakita natin na continuous si F dun sa number na yon, pero yung choice of delta ay hindi nakadepende dun sa number kung saan natin tinetest yung continuity. Ibig sabihin, kumuha ka dyan ng kahit anong number, yung magkakaroon ka ng isang delta na mag-work para mapakita na lahat ng number na yon ay continuous, na si F ay continuous sa lahat ng mga numbers dun sa interval na ito. Alright? So in particular, sure tayo na si bakit x plus y? Yeah, I'll need to check this. But I think this should be x minus y less than 20. Dapat ito ay minus. Kasi nandito tayo sa interval negative 10 to 10. So pag kumuha ko dyan ng kahit anong element x and y, I know that the distance between x and y is less than 20 units. All right? Kasi 20 units lang yung haba ng buong interval. All right? So let me mark this, okay, for correction. And then pag pumili ka ng kahit anong epsilon, you can do the preliminary analysis, and doing so will reveal that the choice for delta is epsilon over 20. So ibig sabihin, para mag-prove ka ng continuity ng function f sa kahit anong number on the interval negative 10 to 10, pag binigyan ka ng epsilon, ang sagot mo lagi ay epsilon over 20 para kay delta. And this is uniform for all of those x's on the interval negative 10 to 10. So yun yung power ng uniform continuity. Okay? So as an aside, you can try to work on these exercises, okay? Hindi ko pa napapag-isipan kung pipili ako sa given exercises sa notes ng isasama sa problem set. Pero I probably will, but no guarantees muna. Okay, pag-isipan ko pa siya mamayang gabi. Okay, questions before we go to the last section? Okay, so kung walang tanong, punta na tayo. Last section na to ng unit 3. And it's about a very important result, the Intermediate Value Theorem. Okay? So na parang pahirap lang sa atin nung Math 36 paghahanap ng number K o number C na nakakasatisfy ng conclusion ng Intermediate Value Theorem. But those who are taking Math 175, hopefully ngayon appreciate nyo na yung Intermediate Value Theorem. Una, siya yung naging basihan ng bisection method natin. Tapos lagi itong gamit para sa proof ng existence ng roots at para rin sa convergence analysis. Ano? Pero yeah, Pero madalas na-overlook siya sa calculus courses. Pero when you go to, say, advanced optimization theory, advanced functional analysis, gamit na gamit yung intermediate value theorem. Okay? But before going there, going to the actual theorem itself, dadaan muna tayo sa isang lemma na mas mapapadali yung trabaho natin para dun sa proof ng IVT. Tapos theorem 3. And that's theorem 3.10. Ano? It is the location of root theorem. It's telling us that if you have a function f defined in a closed interval AB that is continuous, then if f of A and f of B differ in sign, so yung isa sa kanila ay positive, yung isa ay negative, then we are sure that there exists a number x sub 0 strictly between A and B such that f of x sub 0 ay equal kay 0. Okay? 175 pips, does that sound familiar? I hope it does. Kasi kung hindi, maminusan ko kayo sa susunod na problem set eh. So dapat this will ring a bell, particularly, parang ano to, ito yung requirement ng bisection method. Ano? Sinasabi niya kasi kapag meron kang isang function na continuous sa isang closed interval, say ito si AB, continuous yung function dito, pero dahil walang isolated point si closed interval AB, ibig sabihin mag-work pa rin yung natutunan natin sa Math 36 na ang graph ng isang continuous function ay kaya nating i-draw without lifting our pen. Pero sa 155 may caveat tayo doon, may asterisk. Ang asterisk natin doon provided walang isolated point yung ating domain. Okay? So ang domain natin dito ay closed interval AB. It doesn't have any isolated point. All right? So ibig sabihin, kaya nating i-drawing without lifting our pen yung graph ni F dito sa closed interval AB. Tapos part ng assumption ng theorem ay yung f of A times f of B ay less than 0. Ibig sabihin, magkaiba yung sign ni f of A at ni f of B. Say, sabihin natin negative si f of A, pero positive si f of B. Tapos si f ay continuous, so we should be able to draw the function or the graph. Sorry, hindi na siya function. So we can draw this graph of the function, okay, without lifting. Bakit ko kasi binabalik? So ganito na lang. Ayan. Pero you know, the behavior of the function can be crazy over the interval AB. Siguro, sige na nga. Yan. So pwedeng ganito yung itsura ng graph ng function, all right? Now, the two conditions, f being continuous on this closed interval and that the function values at the endpoints differ in sign. So that, sabi ng theorem, guarantee na yon na magkakaroon tayo ng roots doon sa interval AB. And here we see there are multiple roots involved, all right? So, powerful itong location of root theorem kasi ginagaranti niya yung existence of roots, pero hindi niya sinasabi sa atin kung sino yung mga roots na yon. So, doon papasok yung bisection method na pinag-aaralan namin sa 175 para mahanap kung ano yung root or makahanap ng isang root doon sa closed interval AB. Pero anyway, ang kailangan lang natin i-prove dito yung existence ng root. Okay? So, paano natin yun mapuprove? Ganito yung ginawa nung nasa lecture notes. Ano? So, una, kinonsider niya yung interval AB. Tapos, hinati niya to sa dalawang sub-interval through the midpoint of AB. So, meron kang interval AB. I-consider natin yung midpoint. Tawagin muna natin tong C. Alright? Tapos ito, yung gagawin natin na tapos pipiliin natin kung sino dito sa dalawa na to yung nagko-contain ng root. Kasi alam natin dun sa interval AB, merong nag-exist na at least isang root. Okay? Tapos ang gagawin ko ngayon, hatiin ko yung interval AB sa dalawa. Interval A to C at saka interval C to B. Tapos, sure ako na yung root ay may isang root sa alinman dito sa dalawang intervals na ito. The root can be here, the root can be here. We're not sure, but we know that at least one of these two intervals will contain a root. Kung nasan man yung root, yun yung tatawagin natin na I1. Halimbawa, nandito yung root, siya yung tatawagin ko na I sub 1, the closed interval A1 to B1. Tapos pag meron na akong I1, hahatiin ko ulit yung I1 into two intervals. So, halimbawa, ito si A1, ito si B1, okay? Hahatiin ko siya through C1, dun sa gitna nila. Tapos sure ako na may at least isang root kay I1. So sure ako either A1, C1 contains a root or C1, B1 contains a root. Pipiliin ko sa kanilang dalawa or pipili ako ng isa sa kanilang dalawa na nagko-contain ng root. Halimbawa, ito naman yung nag-contain ng root. Ito yung tatawagin kong I2. And I will continue the process forever hanggang makabuo ako ng isang sequence ng mga intervals. And you see, dahil kinakalahati lang natin yung current interval para makuha yung susunod na interval, I will have a family of nested intervals. All right? So that I1 is a superset of I2, I2 is a superset of I3, and so on. And not just that, yung length ng bawat sub-interval ay nakadepende dun sa length nung nauuna sa kanila. In particular, it will be 1/2 of the original interval. So you can compute it recursively, pero makikita natin na yung length ng nth interval ay b minus a over 2 to the power n minus 1. Tama ba ito? Parang kulang. Kasi yung I1, ang niya na dapat ay b minus a over 2, kasi nakalahati na yung length ng is gonna be b minus a over 2 para kay I1. So kapag kasi n ay equal kay 1, dapat ito ay over 2. So this should be, wala na tong dapat minus 1. So i-correct ko ulit ito. Kasi si I1, dapat ang length niya ay kalahati ng b minus a. Si I2, dapat ang length niya ay kalahati ng length ng I1. So it should be b minus a over 4. So this should be 2 to the power n lamang, all right, yung denominator. Pero in any case, b minus a all over 2 to the power n will converge to 0. So that means we have a nested interval or a set of nested intervals na yung length ng bawat interval ay nagko-converge kay 0. Now, the nested interval property tells us na, okay, meron silang unique intersection. Isa lamang yung laman ng intersection ng mga INs. Tatawagin natin yung x sub 0. Tapos si x sub 0, siya yung limit ng mga left bounds at limit ng mga right bounds nung ating nested interval, right? So that means this would be the limit of an and limit of bn. So yun yung susunod na correction. Kaya gusto kong basahin itong proofs na to this time para ma-take note ko itong mga maliliit na corrections na to. Alright? So essentially, sabi ng nested interval property, may unique intersection yung mga nested intervals, and not just that intersection will be the limit of the left endpoints and the limit of the right endpoints as well. So tapos, dahil si f ay continuous sa AB, so ibig sabihin ng f of x sub 0 ay equal sa limit ni f of an at saka limit ni f of bn. Alright? Tapos, alam natin na yung hold on, ano nga ba sinabi natin dito? Nakalimutan ko pala, meron tayong assumption dito. Inassume natin sa taas na negative si f of a, tapos negative tapos positive si f of b. Okay? Now, we say that this can be done without loss of generality kasi kung hindi man totoo na f of a is negative and f of b is positive, pwede nating ano ba pwede natin gawin? Pwede kong i-multiply all sides of the inequality by -1 and the proof will be adjusted accordingly. So kung hindi totoo ito or kung ang totoo yung negation niya ng f of b ang negative tapos si f of a ang positive, you can do a similar proof. All right? Yun yung ibig sabihin ng without loss of generality. Madaling i-adjust yung proof kapag yung kabilang case naman yung totoo. And usually we just present one of those two cases, tapos sabihin na lang natin a similar proof can be written for the other case. Or sabihin na lang from the start na without loss of generality. Okay? So dahil alam natin to ay totoo, ang f of A ay less than f of B, then we can say that f of an is always less than 0 and f of bn is always less than and f of bn is always greater than 0. Bakit ito totoo? Well, let's see. Bakit nga ba totoo ito? Any suggestions? Bigla ako napaisip, bakit totoo ng f of a sub n ay less than 0, tapos ang f of b sub n ay greater than 0? Hindi ko pala binasa tong part na to. Kasama daw siya dun sa assumption. Dun sa pagpili ng I sub n. Pero lagi ba siyang totoo sa pagpili ng I sub n? Paisip ako bigla doon. Sige, pag-isipan natin. Bakit yan laging totoo? Sige, tingnan natin. So, ito. Bawa si f of a daw ay, ito si a, ito si b, ito yung function value niya. Ganito yung itsura ng graph. Okay? So, hatiin ko to sa dalawang parts, no? Ito si c. Tapos, ang I1 natin ay yung kung nasaan yung root. Okay? So, nandito yung root. So, ibig sabihin, ito yung I1 natin. Dahil ayan si I1, okay? Ito yung magiging bago kong A1. Ito yung magiging B1. So, sabi rito ay, okay, obvious siya. Yung f of A1 ay negative, tapos yung f of B1 ay positive. Okay? Tapos anong mangyari pag kinalahati ko ulit? Ito, halimbawa, ito yung kalahati niya. Dayahin ko ng konti, figure not to scale. Halimbawa, ito yung susunod na kalahati. Ito yung C1. So, ang root ay nandito na. So, ito yung magiging A2. Ito pa rin yung magiging B2. Alright? Tapos yung root ay nandito. Yung f of A2 ay negative. Yung f of B2 ay positive. Tapos pag kinalahati ko uli ito yung magiging C2. Ito yung magiging A3. Ito yung bagong A3. Ito yung magiging bagong B3. Si A3 ay may function value na negative. Si f of B3 ay positive pa rin. Tapos nandun yung root. So parang ganun yung nangyayari. Kasi at every step, yung right endpoint ay laging merong positive function value. Yung left endpoint, laging may negative function value. Kasi si C, yung susunod na interval ay pinipili natin so that yung f of C na midpoint ay merong opposite sign than one of the two previous endpoints. Okay, kaya nagagaranti natin na laging magkaiba yung sign ng f of an at saka f of bn. In particular, yung mga left endpoints ay laging negative yung function value, Tapos yung mga right endpoints, laging positive yung function values nila. And that's how we get this guy. All right? So ito pala dapat or. Kailangan i-correct. Okay? Then once that is settled, I think tuloy-tuloy na to. So totoo ito. So by the order limit theorem, yung limit ng f of an ay magiging less than or equal to 0 kasi yung f of an ay sequence ng mga negative numbers. So ibig sabihin ang limit nila ay less than or equal to 0. Tapos yung f of bn ay mga positive real numbers. So yung sequence ng mga f of bn magko-converge yun sa isang number that is non-negative. All right? Since these two guys must be true at the same time, then we're forced to conclude that f of x sub 0 ay equal kay 0. Okay? And that means nakakita na tayo ng isang x sub 0 na root ni function f. And that ends the proof no location of root theorem. And essentially, itong location of root theorem, ito yung tinatawag naming bisection method sa 175. Paano makahanap ng root ng isang continuous nonlinear function? Kinakalahati namin ng kinakalahati bawat interval. Pinipili namin yung susunod na interval such that the midpoint and one of the original intervals will have opposite signs. Then we will continue the root, the process until makahanap kami ng isang number napakalapit na dun sa root. But Theorem 3.10 tells us that if you will carry on this process forever, so makakuha ka ng infinite sequence ng mga nested intervals, then essentially makakarating ka, palapit ka ng palapit doon sa actual root ng function f. All right? So 175 medyo baligtad nga lang. Kasi doon, inassume ko na alam na namin yung intermediate value theorem. Tapos, yun na lang. Hindi na kami nag-nested interval property. Alright? So, IVT yung ginagamit namin para sa idea ng bisection method. Kaya lang dito, dahil wala pang IVT, nauna yung location of root theorem, kailangan nating i-discuss ito sa konteksto ng isang existing result. In particular, that's the nested interval property. Okay? And with that in mind, we're ready to finish the unit by looking at the intermediate value theorem. Nandito pa yung notes ko kaninang umaga. Burahin ko muna. Alright? Anong sinasabi ng intermediate value theorem? Parang generalization lang to ng location of root theorem, right? Sinasabi niya lang kapag meron kang continuous function sa isang closed interval, tapos meron kang number k sa pagitan ni f of a at saka ni f of b, then there will exist a number x sub 0 in a closed interval AB such that f of x sub 0 ay equal kay k. So basically, ang idea rito ay ito. So kapag raw, meron kang continuous function sa isang closed interval AB, alright? So halimbawa ito si f of a, tapos halimbawa ito si f of b. So, ang kaibahan nito sa Theorem 3.10, hindi kailangan magkaiba yung sign ni f of a at saka ni f of b. Alright? So, kahit ano yung value ni f of a at saka ni f of b, continuous daw yung function. So, dahil walang isolated point yung domain, kaya nating i-drawing yung graph without lifting our pen. So, halimbawa ito yon. Alright? So, halimbawa ito si y equals f of x. Alright? So, sabi ng intermediate value theorem, sa kahit anong number k sa pagitan ni f of a at saka ni f of b, pumili ka dyan ng kahit anong number, say, eto si k. Alright? Lagi daw akong may mahanap na element ng closed interval whose function value is equal to k. Is equal to k. Ibig sabihin, iti-trace ko lang to. Oops. Ayun, function value si k, pero dapat yon ay nasa loob ng closed interval, which is the case. Sabi niya yon, ang pipiliin natin na x sub 0. Okay? So yan yung sinasabi ng intermediate value theorem. Tapos madali lang yung proof nito kasi meron na tayong location of root theorem, right? Sinasabi, ang requirement kasi sa location of root theorem, dapat magkaiba yung sign ng f of x saka f of b, all right? Tapos, okay. Yeah, yun lang yung kailangan. Tapos continuity rin. So, gagamitin ko yung location of root theorem para ma-prove tong intermediate value theorem. Pero ang maganda rito, mas madali itong tingnan graphically. Paano ko gagamitin yung proof ng location of root theorem? Well, ang gagawin ko lang, so meron akong graph na yan, i-consider ko yung function na magiging root si k. Alright? So in particular, i-adjust ko lang to. Oops, sorry. That pala sinama ko to. Okay. Ang gagawin ko, magko-consider ako ng isang function kung saan gagamitin ko yung location of root theorem. Okay? Pero kailangan magkaiba daw yung sign ni f of a at saka ni f of b. Now, I want the number x of 0 to be the root of that function. So ang gagawin ko, i-consider ko lang yung function na oops, ano nangyari? Ito. Ibababa ko lang yung function f. Alright? Ibababa ko siya by k units pababa. So, ibig sabihin, ito si f of y equals f of x minus k. Ang gandahan dito, pag ibinaba ko yung graph k units, okay, si x of 0, the function value, na alam ko ang function value niya ay k, ay magiging root na ng function f of x minus k. Alright? Tapos ang kagandahan nga lang dito, pwede kong gamitin yung location of root theorem because look at my picture here. F of a is positive, f of b is negative, they differ in sign. The function f is still continuous because all we did is translate it down. Or if you want to be more analytic about it, the function f is continuous. We know that the constant function is continuous. Continuous minus continuous, it's still a continuous function. Continuous function siya. Tawagin nga natin tong g. Ang g of a ay positive, ang g of b ay negative, they differ in sign. So by the location of root theorem, okay, si g ay merong root dun sa loob ng interval ab. In particular, that root is x of 0. So that means g of x of 0 ay equal kay 0, or there exists an x of 0 in the closed interval such that g of x of 0 ay equal kay 0. Pero anong ibig sabihin kung si g of x of 0 ay equal kay 0, si g was defined to be f minus k. So we translated the f of x k units down. So that means this guy is f of x of 0 minus k equals 0. So that means f of x of 0 is indeed equal to k as desired. Kasi remember, gusto natin makahanap ng isang element ng domain na ang function value under f ay equal kay k. And there you go. Ang nakuha natin ay yung ni f of x minus k na magsiserve as the function value we wanted for IVT. And the proof or the guarantee that x of 0 exists ay yung theorem 3. Yung theorem 2.10. You see, parang andali ng proof. Hindi pala parang. Andali ng proof kung visual ano. But unfortunately, you need to write the formal proof. So for that, I will ask you to read the proof na nabigay dun sa lecture notes. Pero yung idea, ito yung in-illustrate ko ngayon. Though I need to make some corrections here. Okay, nasa nga ba yung i-correct ko? Okay, g of x should be f of x minus k in the x. Kasi nga, kailangan ko siyang ibaba k units. So this is to be corrected. And then what else? G is continuous, g of a, g of b, okay, there exists. And then this one should be k. Okay, and I think that's it. And we are done. Okay, any questions? You're not sa gitna. Tahimik nyo wala man lang nag-react today as afternoon good morning. Totoo talaga, no? Para kayong yung pamangkin ko. Yung pamangkin ko kasi nag-online class din, ano? Tapos, actually sila nga, required sila na sa synchronous sessions, ano? Pero, Lagi ko yung naririnig pagka maaga ako nagigising. May klase yun. Tapos di attentive siya. Good morning, teacher. Ganyan pa siya. Tapos naka-off na yun. Mag-mute na yun. Mag-off cam na yun. Tapos magbubukas na ng YouTube sa tagiliran. Ano? Tapos makikita ko na lang pag tapos na yung klase, bigla na lang, goodbye, teacher, na kunwari nakikinig. So, ganun din ba kayo? Tapos yung pamangkin kong yun ay 8 years old pa lang. So, ganun na siya kapasaway. Ano? So, but anyway, I hope you got the gist of what we discussed today. Any questions, clarifications? By the way, sorry guys, I had a lot of proposals to write the past actually 2 weeks na akong puro sulat ng proposal. Hindi ko pa rin nagagalaw yung homework tree nyo. I'll try to grade it over the weekend, ano, para habang gumagawa kayo ng problem set 2, ay nakikita nyo yung solution, yung comments ko dun sa inyong homework problems, right? So I'll try to do that over the weekend. So yun, and then I'll upload the problem set, the questions tomorrow. Okay, 9 p.m. at the latest. All right, any other questions or concerns? So kung wala na, let's end early today. So for the parang first time no na maaga tayo natapos 10 minutes early than dismissal time. So if there are no more concerns, then have a good weekend, guys, and then don't forget to vote on Monday, and let's see each other again on Tuesday. Bye, everyone.